Hello, hello. Another day, another time to try this out again. There's some music on. Take that off screen. Alright. It's gonna be part 2. We're gonna say part 2. Save. Alright, so we're gonna go on part 2 and let's go to the blog from the other day. Blast in. If anyone wants to see the blog from part 1. Alright. So, some of the learnings that we had from last time were around that we're kind of blocked by the GIL, the global, or what is that called? The global interpreter lock. So Python can only run on his like one bytecode on one core at a time. So if you have 12 cores, you can run 12 parallel processes. So we're not going to really have the ability to get around to that. So we're going to try to do it around memory. And there's two different methods I want to use. One is mmap, which is just a different way to parse through a file and do grouping. So we're going to try mmap, and we're going to probably just let's try mmap first, see how that goes. We'll think about increasing the chunk size. Use as completed to merge the partial results earlier, which I believe will use up a little bit less memory. But maybe we'll just throw it all in at once. So we'll just do once. So nvem main. So I was looking up the documentation before Python mmap. You see, I was looking up before. So let's get a Medium article if I can read the whole thing. Yep, cool. Memory map file object maps a normal file object into a memory. This allows us to think it's using RAM. So memory map file objects have both byte array and file objects. Hence, all operations can be performed on a byte array, like indexing, slicing, assigning a slice, or using RE module to search through a file. Okay, and the operation which can be performed on the file object, like reading and writing data starting at current position, or using seek to position the current pointer to different position. Okay, let's see this. You have file number, I guess, length of the file, tag name, access default, so it could either like read access or something. File dot, okay. Oops. Length bytes from the file specifically handled by the handle file descriptor in Unix file and O, and creates A mmap object file returns the file descriptor of the stream as a number. Okay. Let's see how this works. So you're writing bytes as files. So you're writing bytes to the file. You're opening it with reading bytes. Mm is equal to format file and blah blah blah. Okay. Okay. See, we just want to be able to read. Okay, access read. Read only. Access read. So with mf f dot file. Okay, as file. Print first 10 bytes. Okay. Okay, so just slicing. Slice the chunks maybe. I know a glow boss. This is in my pants. Again, boy. Die as a robot. What's a robot? And I don't have a drink, that's great. Alright. So first thing we need to do is say, import mmap. Oh, I guess you can, yeah, import mmap. So that's not gonna change anything for stat factory. Let's turn this into a dictionary. So we're still gonna open this, but we're gonna read bytes as file, or as f, whatever. Right here we're gonna do is equal to mmap f dot file no 0, then access. We're gonna do the read access equals mmap dot or what is it? Read. Oh, access read. Okay. And we can kind of just get rid of that. If start is not equal to 0, still need that. Yeah, we're gonna say new line is equal to dot find byte new line start end. And if new line is equal to -1, dot close. So we're gonna close the memory out. Then return nothing. Okay, so but if start is equal to 0 and it's not equal to -1, then we're gonna do start equal to new line +1. Alright. So now we gotta do a position. Position is equal to start. So let's just do while true. Oh, well, hold on. Let's do Python. 41 40k. Okay. Oops. Where am I? Okay, right here. So while true, new line is equal to mm.find. Same thing that we had up there. Finding that new line, passing the position, because position is equal to start and end. So now we got that. If new line is equal to -1, break out of it. Then line is equal to dot or position new line. Then position is equal to new line +1. Alright. We're gonna have our separator or delimiter, whatever, line dot find, byte of course, semicolon. So we're gonna find that semicolon, which is gonna split us up. Right? Then if separator is less than or equal to 0, then we're gonna continue to the next one. So just in case the line doesn't have it, stn is equal to line up to the separator. So everything basically before the separator right there, which is the station name. Then we're going to just get rid of this. Alright, so what do we do here? So we get a temp float line separate her +1, then everything after it. So basically just, get into the semicolon like spot, then you have to increase the index, do it as your indexing, and get everything after it to get the what's after the semicolon. We're just gonna decode it ASCII. Oh, here's equals strict. Alright, and we can get rid of all of that. And we're gonna say exception. Probably just keep that as continue for now. We'll be fine. Then aggregate is equal to stats.get station. If aggregate is none, aggregate is equal to temp 1. So it's gonna be the min, sum, max, and count right there. And we're gonna do stats station is equal to the aggregate. So else if temp is less than the aggregate at the 0th index, oh no, not the O index, the 0th index, then aggregate 0, go to temp, ag 1 plus equals temp. If temp is greater than aggregate 2, aggregate 2 is equal to temp. Aggregate 3 plus equals 1. Okay, that would be after the while loop, so we're gonna have to close out of it. Oh no, stop playing the same song. That's a little bit better. So now we're gonna have to return stats, but it's already in the dict because we declared the dictionary up top. That should be good for that. This should say the same for the parameters. Size, chunk size, max. Let's just do max 1, then kind of just, you know, if there's nothing left. Start is equal to 0 for I in range num chunks and is equal to size if I is equal to num chunks minus 1 else min size start plus chunk size. And to just kind of and still do start to is equal to n. Alright, 32k. CPU count or 1. Still got the same file that we're using. Right, num chunks equal to max threads times 3. So basically just threads times 3. Num chunks not access. Yeah. For time, same. Keep that there. Default text claim def, float, blah blah blah. Max workers equal to threads. Executor features, executor submit. All that good stuff is still good. Other than threads right here, we're gonna do num chunks, so that's using that thing right here. We're getting just the larger or more chunks instead. So same amount of threads, just more chunks. So that way we can use a little bit less memory. So we're gonna say as completed. This is what I wanted to use. Then that should stay the same. The items, merge station, if min. Okay, so we're gonna change this up a little bit. I'm gonna say if less than aggregate 0, aggregate 0 is equal to mn. So we keep that. If max is greater than aggregate 2, aggregate 2 is equal to max. And that should be good for there. Results. Oops. So we're still going through the merge keys. So that. Alright, I think that's about it. Python main. Oh, hold on. Oh, oops. What line is that? 33. Let's see if there's. I don't see anything else. Alright, so that's about done. It's kind of. Open up a new one. CD documents. One button row challenge. cd typescript. Mm. Alright, so I think that's about all for this challenge right now. We're gonna let this run, and same thing as yesterday, whatever, or 3 days ago, I don't know. Whenever I get this done, I will post the results, and hoping for the best in this case. We were at 40. Oh, hold on, let's go look at this. We were at 45, just about 45 minutes, over 45 minutes last time. So if we can get down a few minutes, even half the time would be nice. So, and this is the last submission that I'm going to do for this for myself. I kind of keep it at 2. And remember, I'm doing this locally. I'm kind of curious of other people's options. Like, so Python 1 billion row challenge. Okay, let's actually read into this then. Oh, from 10 minutes to 4 seconds. 4 seconds. Could you imagine? Obviously, I don't have much CPU on this compared to what these people probably had. We can go ahead and read this. And let's turn off this music or just turn it way down. Alright. I'll just turn it down on my thing. Let's see. Is anyone even in here? Probably not. That's fine. So, the question of how fast a program language can go through and aggregate 1 billion rows of data has been gaining traction lately. Python, not being the most performant language, naturally doesn't stand a chance, especially since the current top performing Java implementation takes only 1.535 seconds. Holy shit. Oh damn, this is finished. Oh shit. We were actually finished. That was awesome. 162.52 seconds. Holy fuck, that's awesome. That's just, what, 4 minutes? 16 divided, yeah. That's 16 divided by 6. That's 2.5 minutes. Damn. Well, let's go ahead and read this real quick first and see what we can see. The fundamental rule of the challenge is that no external libraries are allowed. My goal for today is to start by obeying the rules and then see what happens if you use external libraries. Oh wait, what am I sharing out right now? Yeah, okay. External libraries and better suited file formats. Well, I'm not using any external libraries because I didn't do any pip installs for that. That's all Python based. I've run all the scripts 5 times and averaged the results. As far as the hardware I'm using, with 12 CPU cores, 36 gigabytes of RAM. Your results may vary if you decide to run the code. Hopefully, you should see a similar percentage. What is the 1 billion row challenge? The idea. Okay, I understand the idea. Once you generate the dataset, you'll end up with 13.8 gigabytes semicolon separated file to columns. Okay, cool. Yep. I understand. Oh, what the fuck? Stupid medium. I was actually reading that. Dumbasses. Let's see if we can actually read this whole thing. Okay, we can read this. Alright. Simple no optimizations approach, blah blah blah. Would be quite slow for file, yeah, so he's just running it, ATF encode, opening it, as file, CSV. Okay, well we have a TXT file, not a CSV file. Import mmap, which I did. Parallel processing plus mmap and chunking, okay. Advanced optimization, custom data structure, pandas, okay, pandas external, so that does not count. Don't care. Alright. Yeah. But no, that's really awesome regardless. So let's oh, this is the same guy from earlier that posted it on Medium. I just want to see your code. These are, oh, okay, so these are the times that he's had, I guess. Total time. These times. Performance on MacBook. I don't understand this too much. Anyways, so altogether, we've done really good optimizing this. We've gone from 45 minutes down to 162 seconds, so let's go ahead and just take this screenshot. We're going to do that, showing files. We're going to go to properties, we're going to actually rename this file. Oh, rename. Python 1 billion row challenge part 2. So let's get that path, move this here. Oops, I didn't mean to move all the screenshots here. Move, move, screenshots, there. Move screenshots. Yes, 1. Oh, damn it. Ah, shit, man. Python 1, then row challenge part 2. Oh, wait, no, I need to. Damn it. I need to move this Python 1 billion row challenge to this. Alright. So now we have that. Test data.txt and boom. Okay, no. Remove test data.txt. Alright, so there you go. Alright, well, that's actually a pretty short one today. So I'm gonna call it a day. And the next implementation will be in Typescript. So first you have to, learn how to get this printed out in Typescript, because printing out things in Typescript in the terminal is kind of a pain in the ass. But it would be fun, I guess. I heard the parallelism is hard in TypeScript, just like Python has its own limitations as well. So that'll be